What distributed and network control systems are? Where do we find them? My name is Themistoklis Charalambous, and my research deals with distributed and network control systems. I understand that the title is technical, but I promise that by the end of my presentation, you will be able to understand the basic concepts and recognize such systems around you, but also see the foreseeable applications that are coming upon you. So traditional intersections consist of traffic lights that follow a periodic change of phase irrespectively of the traffic. Now, more modern traffic lights incorporate wireless communication capabilities that allow further information to be used for traffic control, but also for routing in urban areas, for example. There are already traffic lights that become green in a smart way, for example, for ambulances that are on a mission. And I guess you have noticed that already. Now, the wireless channel is shared among several cars that aim at communicating with the wireless intersection system. In several occasions, the cars interact not only at the intersections, but also when they are in the same lane. So, for example, the decisions of the yellow truck affect the decisions of the red car following it. So, in such cases, we say that the cars have physical coupling. To put this into perspective of the title as well, by considering that the car is a system, and as a system needs to take some decisions, the information needed for taking these decisions are communicated via the wireless network that we mentioned already. So we say that the loop is closed through the wireless channel. Now, if we represent this more in an abstract way, this is what we call a network control system. And unlike other control systems, traditional control systems, the network brings communication impairments such as limited connectivity, which cause packet losses, delays due to retransmissions, and so on, as well as limited capacity that requires coding and quantization. Now imagine that we have multiple systems. This brings extra complexity, and then apart from all the communication impairments, we have interference that causes also congestion. On top, we have physical interaction and dependence of that systems, and this introduces even more complexity into our problem. For such setups, we can no longer neglect the challenges that they bring of taking decisions in a distributed fashion, where the information that is being exchanged is local, and also the communication has to be with no delays, what we call real-time communications. These kind of network control systems are building blocks of a bigger movement of industrial digitalization, often called Industry 4.0, but also as Industrial Internet of Things, smart manufacturing, or even cyber-physical systems. The range of applications is immense. So to name a few, apart from transportation systems that we've seen already, we can meet them in industrial automation, wireless industrial automation, as well as in smart energy networks, where the existence of several sensors allow power grids to be smarter and take decisions based on the information available, as well as in cloud computing. Now, imagine that we remove the traffic lights and the infrastructure altogether, and now we allow the cars to communicate with each other and take decisions without any infrastructure. With the proliferation of autonomous cars, future intersections are actually envisioned that they will not have any infrastructure and that the decisions will be taken using peer-to-peer communications. Now, in terms of systems, we can model that every car is a system and it communicates with the neighboring systems. This is what we call distributed systems, and you can see already the complexity of making decisions cooperatively in a distributed fashion. Now, imagine what happens when we are going to a large network where distributed coordination becomes a very challenging problem. Now, these kind of problems can be modeled as graph-like structures, and apart from transportation systems, as we've seen already, They find applications in a wide variety of areas, such as social networks, edge and cloud computing, as well as the internet, where we have internet congestion control. Now, as you have understood, this research area requires contributions both in control and communications. But apart from individual communications that are modular in each area, we need to make contributions at the intersection of the two, aiming at bridging the gaps and creating marginal links between them. So I hope that by now you understand what the title means, and also I hope that by now I have made you see what distributed and network control systems are, and that you can find them all around us and you can see the foreseeable applications. Thank you.